webcast is now starting. All attendees are in listen-only mode.
Hello, thank you for joining us for this session, Tools for Getting to Zero in School New Construction. I am Connie Empress, Communications Manager here at New Buildings Institute. Before we begin, I have a couple of housekeeping things to tell you about. First, you are muted and we cannot hear you. This helps keep the background noise down so that everyone can better hear the speakers. I want to direct you to the dashboard that you should be able to see on the right-hand side of your screen. If you are having technical difficulties and cannot see the slides or hear our speakers, you can use this question pane in the dashboard to let us know, and we will help you as we go. Please ask questions in this question pane as they come up. We'll take a few questions at the end of the presentation. As the webinar session ends, you will be given the opportunity to take a short survey. There's a place in this survey to submit your AIA number to receive credit. You will receive a follow-up email tomorrow with links to the recording and slides for this session. Today, we will be hearing from Riley Loveland, Project Manager here at NBI, and Paul Torsellini, Principal Engineer at NREL, the National Renewable Energy Laboratory. Paul is the Principal Engineer for the Commercial Buildings Research Group and has been at NREL for 19 years. Prior to this role, he was the Group Manager for the Commercial Buildings Research Team. He also spent 3 years as a technical advisor to the U.S. Department of Energy in Washington, D.C. Paul was an instrumental part in creating the process to achieve zero energy building status for NREL's research support facility. Riley Loveland's focus here at NBI is on energy efficiency in schools. This work includes developing educational opportunities and resources for better understanding of zero net energy. Riley, I'll pass it over to you.
Thanks, Connie. Hello, everyone. As Connie said, my name is Riley Loveland, and I'm a project manager over here at New Buildings Institute. And welcome to the webinar, Tools for Getting to Zero in School New Construction. Before we start, we'd like to thank the California Investor-Owned Utilities Proposition 39 Z&E pilot program who are sponsoring this webinar today. For those of you seeking continuing education credit, here are the learning objectives for today. I'll take a minute so that you all can read them in case you need to. So just for some background on the New Buildings Institute, we at NBI research and define leading edge practices and technology applications for high performance buildings, and then we translate them into these innovative and practical solutions for the utility, energy efficiency, and commercial building industry, which includes schools. During this webinar today, I will be discussing some of the tools and resources available to you on your path to zero energy in schools. So for many years, NBI has been researching and tracking zero energy buildings. And these are these energy efficient buildings that use on-site renewable sources to produce as much energy as they consume over the course of a year. So we started this tracking when many people believed that zero energy buildings were not even possible. Yet we knew of examples through our work in the industry, and we had heard about it through word of mouth. So we started counting and studying them and really putting them on paper. And now we maintain the largest database of zero energy buildings. And because of that, we work to identify and research and analyze these buildings that are the leaders in low and zero energy performance. And with all that data, we each year publish a list of these buildings to demonstrate the feasibility of achieving zero energy. And as you can see from 2012 to 2018 here, we've actually seen over a 700% growth since 2012. All of these are available on the New Buildings Institute website. So this year, we actually isolated the school data from that full database to publish the 2019 Zero Energy Schools Watch List. So this document serves to raise public awareness of the districts and teams who are pursuing that goal of zero energy in educational facilities. And it's available for download and really serves as a tool to connect you guys as interested districts and schools to those with experience in zero energy to share your stories and share your path. And as a quick note, if you're going through both the watch list and the full Getting to Zero list, if you don't see your project on this list, please let us know. Our information is only as good as all of you. It comes from all of you. So please submit your projects if they've not been counted. You can email me. My email will be on my last slide, or you can email info@newbuildings.org. So from our database, we've been able to research these key commonalities in successful zero energy building projects. And one of the key steps is to utilize the integrated design process. So hosting an integrated design charrette early to help define goals, set expectations, and importantly, establish absolute energy targets. This allows key stakeholders, like let's say owners, facility managers, and the building occupants to share their perspective at a time when input can still be easily, and very importantly, inexpensively incorporated into the design. So NBI has developed this Zero Energy School Charrette Toolkit to help lead you through the process of planning, hosting, and executing a successful Zero Energy School integrated design charrette. This toolkit, for example, includes checklists, sample agendas, a sample email invite, activities, discussion topics, and other templates that you can use throughout the integrated design charrette before and after. So another one of the key steps to a successful zero energy project is engaging stakeholders and gaining the support for your zero energy vision. Different stakeholders obviously have different priorities like we all do and needs, and thus it's important to communicate with them on a level that speaks to their needs. So the Zero Energy Schools Stakeholder Messaging Guide delivers 6 key messages for communicating the importance of building to zero energy in schools and provides supporting facts for each message. So additionally, the document can also help you better understand your stakeholders before engaging them. It outlines their missions, priorities, and delivers other key pieces of information for those stakeholder groups. This can be found on our website. So the next 2 slides are some examples of these 6 key messages for communicating zero energy. And I'll move through them pretty quickly, but the slides will be available for download after, like Connie said, and then also available in the stakeholder messaging guide. So there's a wealth of data out there about the benefits of these high performance zero energy schools, and NBI has done a bunch of work to gather this data so that when you're communicating with your stakeholders, you can be prepared with how these schools improve student performance. We know that they're healthier and they contribute to a more productive atmosphere for both students and staff. And we have this here provided in an infographic, and we've also authored an article about these benefits for you to physically pass on to your stakeholders. And communication, of course, is an integral part of any process, but especially the zero energy design process. This relates back to the integrated design toolkit and the stakeholder messaging guide. So in partnership with the CPUC, the California Public Utilities Commission, NBI developed a communications toolkit with a suite of tools to help communicate your zero vision. This includes fact sheets, PowerPoint templates that you can take to your stakeholders or take to not only gain support for your vision, but showcase your vision or showcase what you have done to pass on to other school districts and other interested parties. And then as you can see on the left-hand side here, there's also the Zero Net Energy Project Guide that will help you move through your entire zero energy project. This guide provides step-by-step guidance and checklists to help you move through the entire design and construction process. So all of these resources and so much more can be found on the Getting to Zero School Resources Hub. It's important to note that this is at gettingtozeroforum.com as opposed to .org, excuse me, as opposed to at newbuildingsinstitute.org. But it is an affiliated website. So in addition to all of the resources that I previously mentioned, it highlights outstanding policies, programs, and strategies that school districts are implementing on their path to zero energy. We also have information about energy targets and template materials on how to physically use them in practice. The hub also includes other technical tools, all the guides that I mentioned, case studies, fact sheets, and just about anything you could think that you might need to get to move forward on your path to zero. And just a quick spotlight on the case studies. We have case studies that include schools from around the country, and they highlight both new construction projects and existing building retrofits to zero energy. And a great way to pass the mic off and introduce our next speaker here that was mentioned by Connie is showcasing an additional hub for school resources that has been curated by the Department of Energy. And a little bit of background, the Department of Energy runs a Zero Energy Schools Accelerator program for schools on the path to zero. And through this program, they've developed a set of resources and steps to help schools as they develop their plans to zero energy. This is really helping drive the market on a national scale. All of that information can be found at this link here down below. So on that note, Paul might have more to say on this, but Paul, I'm going to pass it off to you. Thanks, everyone.
Okay, thanks, Riley. Go to both of those websites, have a lot of resources to get you on the pathway to zero and achieving that goal. And I want to talk a little bit more about that goal and setting that goal and some resources that we've put together at the National Renewable Energy Lab as part of DOE Building Technologies program around schools. And so as we move into this, we're going to talk about the Advanced Energy Design Guides. And so not only, so DOE and NREL have provided resources for this project. It is a multi-organizational effort, these design guides by ASHRAE, AIA, U.S. Green Building Council, and the Illuminating Engineering Society, IES. And really, it's a collaboration of these major players in the building industry to put together guidance documents around achieving very high levels of energy efficiency. Each guide is put together by a team of industry professionals that have worked in this space, and there is an oversight committee that is made up of membership of each of these committees. During the development of the guides usually are about a 12-month development process. We do technical analysis, energy simulation, gather the committee together to put the ideas on paper to actually produce these design guides, and go through an open peer review and commentary process to make sure that we're getting the industry input. In the last 15, 16 years or so, we have published a number of these guides. We started with a series around 30% guides, and then later moved to 50% guides. And in total, we put together 11 guides related to the 30% and 50%. You can see some of the different topical areas here. And last year, we put together a guide for Zero Energy K-12, and that really launched this new series. I will point out that the guides are highly circulated. They are available as a free download, and there's over 600,000 of these available or out there today. So when we looked at the Advanced Design Guide for Zero Energy Schools, this guide specifically looks at definitions and process around low energy buildings, as well as what it takes to get to zero. Those solution sets were developed by simulation and case studies and experiences of the team that put these together. They are a mix of prescriptive and performance-based solutions. And they are dependent on climate zone. So depending on the climate zone, you will get a different family of solutions and energy targets. There's a lot of guidance on very specific strategies. You can kind of think of it as an idea book to go through with lots of different ideas, different pathways that will get you on the road to zero. A lot of it is discussing whole building integration approaches and additional considerations to think about some of these technologies. While everything is available widely and is available from at least 2 manufacturers, a lot of times some of these new technologies come with some cautions, and we point those out in the guide too. An example might be that you don't just replace a hot water system with a heat pump hot water system, that there are definitely some things you need to consider when making those technology shifts. We do provide recommended energy targets in terms of how many BTUs per square foot is allowed in these buildings. And we give examples to show that the technologies have been shown to work together and that the targets are achievable. This is real measured data from these buildings. So to step back a step here, to create a zero energy building, it really takes 2 pieces. And it's important to remember those 2 pieces. The first one is to increase the energy efficiency. and really hone in on efficient construction, efficient systems and appliances, what's going on with the maintenance, and even how users will view this new technology. And yet get a building that is pretty simple to work and is achievable to hit the goals. That energy efficiency is first and foremost to make these systems work, as opposed to saying, I'm going to create a typical building and I'm going to put a lot of renewable energy on it and call it zero. Really, it's a balance. And partly, if I reduce energy consumption of the building, that is less renewables I have to bring onto the site in order to call it a zero energy building. There is a formal definition and there's a resource on our web pages on DOE's definition for zero energy building, along with samples of how to do this calculation, where an energy efficient building on a source energy basis, the actual delivered energy is less than or equal to the on-site renewable exported energy. And it really is talking about getting that consumption down and then meeting that load with renewables. So when we put together the Advanced Energy Design Guide for Zero Energy K-12 schools, we were really looking to address some barriers that we've heard in the industry that folks were coming to us with and saying, how do I overcome this? One was to demonstrate that zero energy schools are attainable, and to provide direction for how to design those buildings, how to construct those buildings, and show that it can be done in all climate zones. And to offer methodologies that are financially feasible, that are acceptable to school districts as operationally workable, and that they're readily achievable, that this is not something that somebody's dreaming up, it's highly complex, it's overly expensive, and to identify what those measurable goals are and communicate that back out to the industry. In the guide, we have several sections, and if you're familiar with previous advanced energy design guides, the chapters follow a very similar pattern as the previous series of guides. Really, we're addressing multiple audiences. The bulk of the guide is really tailored towards engineers and architects. It's really a how-to and steps and strategies to get to zero energy schools. But there's also large portions of this that are applicable to school owners, whether that is the local community, the Board of Education, the facilities, or the administration, especially the earlier chapters. And there's definitely some very, pointed remarks in terms of setting energy goals and holding fast to those energy goals. If a school owner wants a zero energy building and has set the budget, the challenge, is out there to find design teams that can meet that objective. And one of the things that we're finding, and Riley kind of alluded to it with the inventory and just the growing numbers of these schools, is that it is possible, and it is possible today, and it's possible today within the budgets that we normally see for school buildings. A lot of the introductory material, and again, really focused towards both the owners, but also kind of how to assemble design teams and how to interact with the rest of it, is around collaboration and iteration, that this is not a linear process, talking about how to incorporate energy models early on. I should actually back up one slide before I move forward here. Just to kind of outline the rest of the guide, this part's in the introduction and the rationale. We also have keys to success, building simulation. So talking about using energy modeling to help inform the design process. And then all of these different ideas and strategies are in Chapter 5, arranged by topical area. So going back early in the text, it talks about doing this integration and how to relate that back to energy simulation. That energy simulation should be done often and be used as a design tool up front to really guide the energy goals and to make sure those energy goals hold fast throughout the whole process. And as you can see in this illustration, a lot of different pieces can interact and gain value by using that data that can come out of building simulation or energy modeling. So as part of that, and one of the long-term goals or objectives we've had for these guides is to do a lot of energy simulation up front to show what kind of pathways make sense and what kind of direction to go down. And so we did exhaustive simulations and used those to determine energy use targets that then owners and design teams can use to move forward in their designs. We can show that zero is possible and the types of strategies that are used to get there. The guide is really a set of design decisions that can help achieve those targets. Another term that comes up again, because energy efficiency is so important here, that we're really creating zero energy ready buildings, right? Buildings that are so efficient that on-site renewables can offset the energy needs. We do that because quite often, if you get the building ready to incorporate renewables, and that might be having roof area that's ready for photovoltaics, having conduits in place, having room in electrical closets to accommodate the wiring for these systems. One of the things that we've heard is that in a lot of places in the country, installing renewables actually can be fairly hard and complex. It depends on what the utility is doing. It depends on different states, what rate tariffs are. It even depends where that school is located and what the utility infrastructure can and cannot accept at this time. And so part of it is that you shouldn't just throw out the concept if you can't put renewables on the building. That all buildings can achieve an energy target that makes sense, that's cost effective, and that really prepares for the next generation of buildings where the paradigm has shifted from buildings that are consumers to buildings that are producers. In the DOE definition, there is an energy balance boundary that talks about what is included, how to work with the on-site renewable, how to deal with energy that's imported and exported from the site, whether that is renewable and non-renewable. There's even discussion about, if there's a need to have to use a little bit of fossil fuel, can you offset that with renewables, and how does that happen? It even talks about things like if you end up with electric vehicle charging stations, even though that shows up on the building meter from the utility, really you're taking that energy away from the building. And so we consider that an export of energy from the site. So getting back to the specifics on zero energy schools, we wanted to provide design teams with a methodology for achieving these goals that are financially feasible, operationally workable, and show examples of those. And again, achieving the low EUI is the primary goal. And I've talked a little bit about the issues on-site renewables and whether it's achievable or not. So we do this as source energy. So you can see the EUIs, they're presented as source energy, which includes the energy for all the transmission losses, power plant losses, et cetera, that appear on the utility grid. And you can see that number does change somewhat with climate. It was interesting how close the numbers were between primary schools and secondary schools. We did separate those two out with two different sets of models, and that middle schools fall somewhere in between. Where we got the original basis for this is that if you look at solar energy, and this is a solar radiation data map that NREL produces, we actually shifted this map to look at a two-story school, assuming that we could cover 75% of the roof area, and translated that to a site EUI. So before, on the previous slide, we had source energy. On this one, we have site, that is what is being measured actually at your utility meter. And what you see is that if you're in southern Arizona, you get a lot more sun than if you are certainly like where NBI is located in Washington State, or say in the New England states. And that you need a lot less solar panels in those Southwest climates. And we translated that back to what EUI was needed. And it's kind of interesting because one way to interpret this is in the Southwest, you could actually use more energy in your building and still be able to meet the need with on-site renewables. Versus moving up into New England, where that number actually is very close to what our recommendations are, kind of that 20 to 25,000 BTUs per square foot. But one of the things that we tried to do is we didn't want to just rely on these numbers, because what happened was that a lot of the strategies involve things like managing plug loads, managing lighting loads, which don't have a lot of variation with climate. And so if the expectation is that you can do these things cost effectively in the northern parts of the US, then you should also be able to do the same things in the southern parts. And that was an overlay we put on creating those numbers on this. What is also interesting about this chart, and as we've looked at kind of some of the economic analysis around zero energy schools, is that they are very feasible, especially in the Northeast, even though there's not a lot of sun, but because the utility prices are so high. And so that's something else that you need to kind of think about in the mix of looking at this. There's a table with a whole bunch of numbers here. It is available in the design guide, but it lists the site energy goals for primary and secondary, as well as the source energy goals for primary and secondary schools, all expressed in thousands of BTUs per square foot annually. And you can see that there is a little bit of a variation by climate zone in looking at these numbers. So moving on to chapter 5, we really look at the how-to strategies. And this is really a bulk of the book. In looking at really at small pieces of text with strategies to move towards zero. Those strategies are divided into different sectional topics. So different disciplines on the design team can focus on different areas. And there are cross linkages between those different areas so that, for example, designing the renewable energy system might depend on how the building is designed and the site planning issues, because you're trying to free up roof area. And there's cross references between the two. The lighting depends on, and especially getting into daylighting, some of the facades that are used and how the windows are placed and how the overhangs are placed. And that also is kind of an envelope building planning. So there's a lot of intertwining that goes on here. And in the strategies, and if you download the PDF version off of ASHRAE's website, you actually get those as hot links to help you get between the different tips and see the strategies. Just to give you an idea of those different categories and some of the example strategies, I've listed a table here with the number of tips that are in each section. And again, the bulk of them has to do with how to get the energy loads of the building down. A lot of people want to ask me, if I had to do it, what steps do I take to do this, right? And so we've kind of created this loading order, as I call it, to kind of think through the pieces. And this is not a pure loading order because there's a lot of iteration that needs to go on here. But the first piece is setting the energy goal. And there's two ways that it comes about. One is that the owner says, I want a zero energy school, and looks in our guidance documents and can set an EUI target for the energy consumption of that building. But likewise, a lot of owners are not aware of these things. But another trend that we're seeing in the industry is that design teams are going to owners and as a value added are saying, would you be interested in a zero energy building without changing the budget? And I will hit these energy use targets. And using that as a competitive advantage in order to show higher value of their design services back to the owner. And so we're seeing both of those trends out in the industry. And we're seeing a lot of owners going out and competing and saying, I want the best architect and engineer to deliver my zero energy school, and they do it competitively. And they've got several qualified companies that are coming to the table with us. So it's definitely out there, and people are realizing that through the work that's being presented in this webinar today, that it is possible to happen. So set that energy goal. It's critically important. Check it often to make sure you're hitting that goal all the way up through operation. Next comes kind of the massing, how it fits on the site, the orientation of the building. You can start running simulations in here to look at the impacts of that depending on the climate. Start looking at the envelope and designing the envelope to include the daylighting, how much glass is appropriate, how do I shade that glass, really getting that envelope down, how much insulation do I need, and most importantly today is how tight can I make that envelope. One of the nice things that has changed in the last several years is that we can now specify that tightness, and there are companies out there that can pressurize or depressurize buildings to verify that that tightness specification has been met. Looking at the plug loads is really important. And a lot of people will say, well, you know, that's not something the design team normally thinks about. It's like, well, yes, it's not something you normally think about, but in these zero energy buildings, what we're finding is that plug loads can easily be half of the energy load of the building. And so it's really important to set those goals around the plugs and get the owners engaged at what that means. Now, what's interesting, and we could have an entire webinar just on plug loads. A lot of times what it means is how effectively do those plug loads turn off when the building is not occupied. I heard a story a month ago or so that a high school had 215 Wi-Fi routers in it, each one using, 10-ish plus watts. Well, suddenly that's 2 to 3 kilowatts just in Wi-Fi, running 24 hours a day. And being able to get that equipment turned off can make a big difference in the energy consumption of the building. When the building is not occupied and nobody is using the Wi-Fi. The lighting loads, getting those lighting loads down, the LED technologies have really helped with that in getting lighting power densities well under 0.5 watt a square foot. And again, getting those lights off when there is adequate daylighting in spaces, or get it dimmed when there's good daylighting, and especially getting it off when the building is not occupied. Once you have all those pieces down, I'd almost like to draw a line there. I guess I could have done that on the slide. Then it's time to think about the HVAC equipment and designing that HVAC equipment after all these other pieces are in place to say, how big of the load do I really need? And what is the most efficient way to deliver that heating, and interestingly, very little cooling to the space to make it work. And that's one of the big changes we see in these buildings, is that the cooling loads go down dramatically. And finally, when all those pieces are done, verify, make sure you hit your EUI target. Once you've got that EUI target, now you can design for your renewable energy system. So just some examples that I picked out of a couple of these. Again, plug loads is a big one. And we have seen design teams really make a difference in how buildings use energy by engaging with owners and trying to understand plug loads. Some of it is controlled. Some of it is controls built right into circuit panel boxes and automated. Some of it is through a building automation system. Sometimes it's with occupant behavior and having good metering and good web-based metering, so that different schools or classes or wings of a building can hold competition on how they're managing their plug loads. On the site planning area, I mentioned already looking at a site analysis, looking how the weather, how the winds behave, optimizing that orientation, maximizing the available roof area, and that goes all the way down to where are you sticking plumbing vents? How are you, if you need ventilation fans on the roof, where are those located, and how much will it interrupt the continuous nature of photovoltaics? And yes, photovoltaics is modular, but it is much easier to install when you've got large continuous racks. And that will also give you the lowest cost for installing those systems. We also looked at, again, I showed that map of the US earlier that indicated what the different EUIs were based on solar radiation. We actually backed that out a little differently and said, based on our EUI targets, what percentage of the roof area do you need to cover in order to get to zero energy, and how is that planning done? What's really interesting is that most of the country, is somewhere below 25%. The hardest climates to deal with are climate zones 7 and 8. They're very cold climates. They have very big heating loads that you need to meet with these systems. Heat pumps don't work as well in those climate areas, and you don't get as much sun. And that sun tends to be low to the horizon when you do get sun. And so those are actually the hardest climate zones in order to hit zero energy with. I talked a little bit before about envelope, but I think it's important to reiterate it. The design guide has lots of examples on the envelope, lots of detailed drawings on how to get the air barrier in, the vapor barrier in, and really get that envelope to work and be airtight. We talk about things like on the right side is a kind of a cartoon drawing of a cross section, drawing the red line on the sections to show where that vapor barrier is, that you know that it's continuous. Looking for thermal bridging. And again, we've got examples of many different construction strategies in the guide to help think about that. I've often copied some of those images so that architects, when they're having a specific detail question, can see how other people have done that. There are also technology examples in there with the how-to tips. So an example of that is daylighting. And in the daylighting section, it shows some photographs, it shows some renderings and schematics of how daylighting could be done in different spaces. And there's lots of different strategies to effectively daylight a space. On HVAC, some of the system choices, we looked at 3 different system choices when we did the modeling, and that was a ground source heat pump with a dedicated outside air system, variable refrigerant flows with heat pumps and dedicated outside air, and chillers and air handlers, kind of a more conventional air-based system with dedicated outside air system. These are not the only systems that work. These were just the systems that we modeled to come up with the EUI. Design teams should look at their individual loads and how those loads are put together and really strategize on how do I create an HVAC system that meets the loads that in reality the envelope cannot meet, right? Think about a building envelope as being your protection between the inside and outside of the space. And the question is, how much can that envelope actually help to heat, cool, ventilate, and light the building? All of the strategies that we selected meet or exceed ASHRAE 189.1. They also comply with other ASHRAE standards, including the refrigerant and also the thermal comfort and outdoor air requirements that are in those respective standards. We do talk about demand control ventilation and start looking at things like acoustics, which is important as you're looking at the overall strategies. Again, we have a little bit of information on renewable energy. The ADG is not a renewable energy guide. There's lots of guidance out there very specifically for renewable energy, but we do provide some recommendations, right? If you're interested in renewable energy, talk to the utility early in the process to understand what some of their limitations are, what their infrastructure limitations are, what the tariff structures are, in order to look at what this means financially for the project. And make sure that you've got locations to put the photovoltaics. Now, it's interesting, I talk about properly oriented. Photovoltaics has gotten so inexpensive that it is okay not to have the optimal orientation, but actually just to add a couple more panels to make up for it. So even things like east and west are not terrible from an overall performance point of view. In fact, there's a lot of discussion that it may help better align with the utility grid and what their needs are. The guide does have case studies in it as standalones with individual EUIs. These are actual measured EUIs from buildings. They come from a variety of climate zones and a variety of size buildings. So the school in the lower right is actually fairly small. Discovery Elementary in the upper right is a fairly large elementary school. And that EUI is well below what our recommendation is for kind of the maximum EUI to get to a zero energy school. Here's just a kind of how it gets typeset as examples. And for these schools, and there's some dialogue, there's photos, there's a list of energy strategies, and energy performance data. And again, this is actual data about the school. Discovery, which I had on 2 slides ago, the aerial, just as a case study back to this, we do provide some of the information that the district provided in terms of what the costs are, including the tariff that they had to make this work, the energy use intensity, how much energy cost was avoided with this project, information about how they went through their commissioning and verification, which is always an ongoing process. And one of their lessons learned was coordination with their local utility. And it delayed the start of the photovoltaic system until after the school was open, even though they started that process early. They have a really nice energy dashboard. You can go to that URL there and look at what they are seeing in real time and what their students are seeing in real time. One of the nice things that Discovery did was they integrated this data right into the curriculum of the school. And so students are regularly collecting this data and using it as part of classwork. So at the end, kind of wrapping up here, one of the things that we had, and it's always a very interesting thing, I chaired this committee, and it's always interesting to have somebody else kind of look at what you've done and provide a review of that information. This was in the Green Schools Catalyst Quarterly about a year ago, this article. And it was a review of, at the time, was the brand new Advanced Design Guide. It's been out about a year now. But really, the quote that came out of this that struck me was that the ADG helps subdue anxiety over additional costs and schedule impacts associated with zero energy design. And that really became kind of our mission for why these guides exist. And we hope that those listening today can take these guides and feel the same way about making design decisions around zero. So just some lessons learned, some of the big pieces. The vision and goals must be established before the design team is selected ideally. I mentioned that before, or the design team needs to bring it to an owner. But all 3 parties there, the owner, the design team, and the contractor ultimately need to share the vision and goals to make these work. An energy efficient building is integrated, that all design decisions are helping to contribute to energy reduction. Every component contributes in some way to it. And that maintaining zero energy is not just about design. It's not getting a design rating. It's really, really the rubber hits the road as the building is operating and you say, did I achieve that performance target? And you can look at this every year for the life of the building to make sure that you're meeting it long term. And it really is a long-term commitment. We're also putting out another document that will be coming out in the next month or so about, and this was actually created by the schools involved with the Zero Energy Schools Accelerator, input from them, but really how to go through these processes and just more detail for owners and how to achieve success. So you can be looking for that resource coming soon. And so I will take questions. One of the things I realized on here is that the URL for the design guide, I don't believe was on there. and it's ashray.org/AEDG, Advanced Energy Design Guide. And so we'll make sure that all the participants get that link before we are done.
Okay.
I will pass it back, I guess, Connie, Riley?
Yeah, I'll take over here, Paul. Thank you so much. Just a reminder, we will be sending out our slides, a PDF of our slides and a link to this on-demand recording. And we will throw in there the link to the guide as well as a resource that was spoken about today. So our first question is, does the guide have particular programs that are preferred for the modeling?
It does not. So our normal recommendation on modeling tools is that they meet ASHRAE Standard 140, which provides guidance on modeling tools and what they need to do. We used the Open Studio platform when we did our analysis, and they're not readily available now, but we plan on actually packaging up those models so that design teams can use those as a starting point. But those are based on Open Studio and with the engine of using Energy Plus as the engine.
Okay, thank you. Is there a similar guide for retrofitting existing school buildings?
So that is a really good question, and Riley, you might have some insight on some of this. There are, if you go through this design guide, you will find that there's a lot of areas in the design guide that are applicable to retrofits, even though this talks about new construction, and that some of the targets apply to all buildings. So we do give, say, an energy use intensity for just the lighting. And lighting is one thing that gets wholesale, redone in buildings, right? And you can specify watts per square foot. And that isn't as dependent on new construction as others. The plug load piece is a huge opportunity for most of these schools, and all schools can take advantage of reducing their plug loads. I know as an organization, NREL took this on 10 years ago, and we did a detailed plug load analysis, and we cut our plug loads 50%. And that was not even trying really hard. It was just looking at the types of purchases we were making and the amount of equipment we had installed. So those are two areas right off the bat that apply directly to retrofit. We are, just as another teaser, we are putting out an office zero energy design guide. Hopefully in June, it's a scheduled publication. And we've actually gone to kind of the extra step to highlight areas of the guide that are very specific or not specific to retrofit, but also apply for retrofit applications, just to help with that question.
I would add too, this is Riley, I echo what Paul says, that this guide and many of the guides out there, although they specifically say new construction or they may lend themselves to new construction, a lot of the steps and there are a lot of commonalities between the process. It's still involving stakeholders and setting absolute energy targets. So although there may not be a guide that specifically says retrofits on it, a lot of the lessons learned from the research done with DOE and NREL and the NBI work really echoes, work that can be done in retrofits. And the one thing I would point to is that California, part of the people who helped fund this webinar, California has something called Proposition 39 Z&E pilot program. So they have done Z&E retrofit pilots across the state, both in North and Southern California. And NBI is one of the advocates and the groups that is kind of disseminating that information. So on our Getting to Zero Hub, there's a page about the Prop 39 program with lessons learned, and just more information about the technologies and processes that these schools are going through on the retrofit process. And again, it's in North and South, so it's in different climate zones, so it may apply to you as well. I would definitely check that out. And one other little piece is that the Collaborative for High Performance Schools, CHIPS, they have guides as well that lend themselves to high performance schools, green schools, zero energy, and a lot of that can be translated to a retrofit process. Connie, are there other questions? Oh, go ahead.
I was just going to give a quick example and just how some of this thinking can evolve, right? So I was recently asked to look at a project. It was actually a gym, and the school wanted to put photovoltaics on the roof of the gym, and they were told that they couldn't do it because of the weight restrictions. They couldn't add any more weight to the roof of that building with the photovoltaics. And as we dug into it, we realized that the roof was near the end of its life. And so we actually pulled off the roof and insulated it and it was a gravel and tar built up roof. We pulled the entire roof off, right, and left down to the metal deck. We put in an appropriate amount of insulation and actually increased it like 4 times the amount of insulation, used a membrane roof on top of that, and that freed up enough weight on the top of the roof that then we could use a balanced PV system. So not only did we better insulate the roof, we made it tighter, we made it watertight, which it wasn't before, and we added photovoltaics, all at the same time. And that ended up being a really effective cost solution by bundling all those pieces together. And that's just an example of you can take those guidance pieces in the guide and apply them, to a retrofit project because decisions were being made about the roof.
That's a great story, Paul. It really goes to show that in retrofits, it's really about evaluating kind of the strategic timeline, turnover of systems, turnover if you're, let's say, going after one part of the school, can you go after the roof? Can you go after your insulation? Anything like that. So that's a great example.
Okay, we had one more question come in. When you install PV, have you run into cost problems with demand charges?
So yes and no. You have to be, and those are the right questions to ask, right? Those questions are in the design guide because somebody needs to ask those questions. Our experience has shown that when you put on the PV system, it usually does not impact the demand charges, i.e. those demand charges don't go down. And you can think of it in terms of a school is running, maybe the air conditioning is running, it's a sunny hot day, the PV panels are chunking out, and a little cloud comes over for 15 minutes, knocks out the PV system, knocks out the daylighting system, and so the lights come on, the PV is basically shut off, and the air conditioning is still running, right? And you will hit the same peak demand charge as if you didn't have the renewable energy system sitting there. And so that's a really important question to ask. Now, how do you address that, right? Well, you address it by saying, you may also want to think about some kind of demand strategies, so that you don't hit those peak demands. And maybe, and you can apply this to any building, even without renewables, is that you want to turn down the air conditioning if you see that you're hitting a peak demand charge. You want to look at things like thermal energy storage. There's other design strategies. If demand charges are really hitting you hard, you also want to do your own metering to understand where these demand charges have hit. I've looked at lots and lots of building data, and to many people's surprise, sometimes they do a setback in the morning or go back to a comfort occupied condition in the morning. All of the chillers come on at once, and they actually hit their peak demand at 6 o'clock in the morning when nobody's in the building, because they didn't stagger those loads or ramp those loads up. So knowing when that peak demand happens is also really important to manage those utility bills. And that's an important part of just collecting data and knowing what that data says. You do have to watch it when you are buying PV systems, that they are actually looking at if there's any demand savings and what the energy cost savings is. As two separate pieces. Do not use what's called the virtual rate, which is kind of an average dollars per kilowatt hour to deliver that, because you will get shortchanged at the end of the day and what that return on investment is.
Okay, if nobody has any last minute questions here, it looks like we have answered what has come in and reached the end of our session. So thank you so much, Paul and Riley, for sharing your wisdom today. And we hope to have you on our next schools webinar on the 25th of April. Thanks a lot. What's happening?